Well, hello. Welcome to this installment of SanfordFlipMath. We are working on PreCalculus, and we are working in section 1.2. We are describing functions. Uh, Basically, what we're looking at is the many ways we can describe the attributes of a function. And these things are, we're going to start out working on functions that we already know how to deal with. And then as the year goes on, we will be using these terms, this vocabulary, to talk about the many facets of the different functions that that we're going to be working with. So these ideas, you need to hang on to them because this is not just a this idea thing. Okay, one other little thing that I want to mention before we get into the meat of what's going on. Remember that this is a video. You can pause it. You can back up. You can replay it. You can go back to it again next week. You can go back to it tomorrow night. You can come back to this as many times as you want. It's going to be there. So take advantage of it. That's part of the point of doing the class in this method. Also, if you need it explained differently, not just hearing the same thing again, but having it explained differently, that's what class time is for. That's why Mr. Sanford's here after school, before school, whatever. But don't feel like it all depends on this video. Okay, I am accessible. Come see me. Okay. All right. Well, let's get to it. We're going to talk about some things that are familiar, some things that are newer, some things that may be brand new. So, all right, we're going to start off talking about domain. Domain, as most of you know, is the set of allowed input values or allowed x values, that the things that you can use, the numbers that you can use, the kinds of numbers that you can use in an equation. Sometimes these things are given explicitly. For instance, maybe we're talking about an equation that models the population of Southfield, and maybe it's only appropriate to use this model between 2008 and 2012, something like that. Okay, so we might say this equation is appropriate for 2008 to 2012, so those are the only years that you would use this. Okay, it could be implied from a situation. Situation might be talking about an equation that talks about the height of a ball flying through the air over a certain time period. So times, maybe it only makes sense to talk about times that are positive, unless you're going to try and go back in time, you know, without a time machine. Or maybe we're talking length and width of a rectangle, and it doesn't make sense to talk about a negative width. Okay. Also, the third way that we can talk about domain is based on what works in a function. This is really going to be kind of our focus this time, and really what we're talking about is stuff like you can't take the square root of a function. You can't take the square root of a negative unless you're going to talk about imaginary numbers. You can't divide by 0. You know, anything divided by 0, 3 divided by 0, 7 divided by 0 is undefined, or if you do 0 divided by 0, that's called it's what we call indeterminate. And if you want, we can talk more about that at some point to get the distinction between the two, but it's not a big deal for what we're doing right now. Okay. All right, so domain, mostly what we're going to be working on is what works in a function, and the other ones will be kind of obvious. Okay. Next up, range. Now, we're going to do some clever abbreviations here. Domain was D, range is, you guessed it, R. So domain was about X, range is about Y. Now, I do love the fact that these are alphabetical. Domain range, X, Y. Even if you go to input and output, same alphabetical order. Okay. So the range of a function is the set of possible output values or Y values. Okay. So here's the idea. If you're only allowed to put in certain X values, then only certain Y values are even going to happen. Those values, a listing of all those values, that set of values is the range. Okay? So I will also say that keep in mind we have multiple representations we can work with. So sometimes you're going to look at an equation and reason through your head, oh look, x squared only gives me positives. I'm going to subtract, so okay, the values are always going to be bigger than whatever. Sometimes you might have access to a table of values and you say, you know what, it looks based on these numbers, these y values that I'm looking at, that the range is these values. I would also say that a graph or a visual is very, very helpful. So here's three of those representations that we're going to see over and over and over again. Okay, so symbolic, numerical, and graphical representations. So I just want to emphasize this. The whole graph thing is very helpful when talking about range. It makes it easier to not miss things. Okay. All right. The third thing we're going to talk about today is asymptotes. And asymptotes you should be somewhat familiar with, but probably not as familiar as domain and range. But asymptotes we will again abbreviate, but we're going to focus specifically on vertical asymptotes and horizontal asymptotes. There are such things as slant asymptotes, sometimes called oblique asymptotes. They exist, but we're going to focus on horizontal and vertical. Okay. So what is an asymptote? An asymptote is a line that the graph or the function approaches. It gets closer and closer and closer and closer and closer to this line, okay, but it never actually gets there when it's doing that closer and closer and closer process, okay? So, and you've seen fractional equations or rational equations where maybe you have something like this, and we'll see one in just a couple minutes, where the graph looks like it's getting closer and closer and closer to the x-axis. So the x-axis, also known as y equals 0, would be an asymptote. Now, just a quick little heads up, every now and then, now this is really rare, but every now and then there are weird graphs. Okay, so I'm tucked over here in the left-hand corner. And maybe there'd be a horizontal asymptote right here. Now, it is possible for a graph to do something like this, where it kind of crosses the line and then starts, dare I say it, acting like an asymptote. Okay, that was the whole word there, yeah. Okay, all right, so that's just kind of a rough idea of what it's about, and we'll do a few examples now, and as many as we can jam in our time. Okay, all right, so moving on. All right, so example 1, and our goal is to find domain, range, vertical asymptotes, and horizontal asymptotes, and what we're going to work with, our first equation is going to be f of x equals negative x squared plus 4x minus 1. Okay? All right, so you should look at this and say, yeah, I know what to do with that. I've been doing that since Algebra 1. Now, so we're going to deal with this specifically with the questions of domain, range, vertical asymptote, and horizontal asymptote. Okay? So domain means, again, what kind of x values are you allowed to put in here? Now, I'm not specifying any specific, pardon the redundancy, asymptote, or I'm sorry, domain values. I'm not saying only use from 0 to 50. I'm saying you can use anything you want, anything that works. Okay? We don't have any context issues. There's no length and width in this. There's no time or height above the earth or anything like that. So there's no context issues. It's all about what works in the equation. So you got to ask yourself, what kind of numbers can I square? Can you square positive numbers, negative numbers, fractions, decimals? All of that, yeah, all kinds of numbers you can square. And you can make them opposite sign too. You can make positives negatives and negatives positive and all that stuff, even though some of that really doesn't apply here. You can multiply any number by 4, and you can subtract 1. So what numbers are you allowed to use here? Any numbers. Well, we have a number of ways to, pardon that pun also, to list this. One way to say is, what numbers can we use? All real numbers. Now, just to be reminded, there are imaginary numbers, and typically we don't use imaginary numbers unless we're in a context that specifically accounts for them. Like if we're doing some electronics work or something like that. I mean, we will do some dabbling with imaginary numbers, but they're not going to come up for a bit. Okay, that's one of those weird topics that pops in and then pops out. Okay, so all real numbers is the way we could list the domain here. There is a shorthand for that, and it looks kind of like a fancy R with a double bar in it, or a fancy bar. Now some books just do some kind of a real loopy-ish looking R. I don't care. Any of those are fine. Just make it look a little more fancy than normal, and so any of those ways you could list it. Okay, you could say also, and you may be familiar with interval notation or you may not, but this says all of the numbers from negative infinity to positive infinity. Okay, so the underlining there is just me emphasizing where to look, but just so you're aware, that's an alternate notation. This would be from the small number to the big number, and since you can never really include infinity because you can't ever get there, these are parentheses, and you'll see a distinction between that notation for infinity and other numbers too in just a minute. Okay, so we have 1, 2, 3 basic ways to state the domain here, and again, it's all real numbers. Okay. Now, range. Now, again, we're talking about y values now. So as you're looking at this graph, you really need to be thinking, all right, I know this thing, because this is quadratic, this should be a parabola. Okay, please have the emphasis on the correct syllable. Parabola, not parabola. Parabola would be like if you had a set of bowls, 2 of them, but this is parabola. Okay, so the idea is that this thing is going to look U-shaped, either up or down, and most of you should be able to note that because of that negative in front of the x squared, it's going to be something like this. So is every y value in the universe going to be part of this? No, because it's not going to keep going up forever. In fact, it's going to have a maximum, and it's only going to be that maximum and everything below it. So I'm thinking to myself, this is kind of a complicated mess. I'd like to be able to look at a picture of this. Okay, well, there are a couple of ways to do this. Obviously, we could do this in the calculator and graph it. I'm going to take just a second and remind you of a little bit of math from before, dare I say it, symbolic math. It looks like a little chunk of the quadratic formula, and really what this does is gives you the axis of symmetry for the parabola, or in other words, the x value of the vertex. So if I follow the standard format, so b is 4, so the opposite of 4 would be negative 4 over 2 times a, the coefficient of x squared. This is negative 4 divided by negative 2, also known as 2. So I know that the vertex is at 2 something. Okay, well, it'd be nice to know this something. Well, if you want to know a y value, this is y. Y equals this whole thing. So I just take that 2 and put it in there. So negative 2 squared is 4, plus 4 times 2 is 8, minus 1, so 8 minus 5 is 3. Okay, so I know the y value there is 3. Now, it's up to you. We could do a whole table of values here, but being, you know, the lazy person I am, I'm just going to make note that, oh yeah, remember this is the vertex and this bad boy opens down, so let's just kind of take it down. All right, so there it is. All right, so as we look at this, as we're looking at this graph, remember that the whole reason for doing this was to look at the range. Okay, so I see that there's a top to this thing at y equals 3. And then all of these other y values are going down from there. Are fractions included? Yep. Decimals? Yep. Positives? Yep. Negatives? Yep. Anything below that 3 and including the 3. So one way to write this would be to say y is less than or equal to 3. Now, if you got a little fancy, there's set builder notation, which says the set of all y such that y is less than or equal to 3. In essence, the same exact thing, just a little fancier. Some people are sticklers about that. I tend to not be sticklers about a lot of things. So worth noting that some books put a line there instead of that colon. Okay, and again, if you were going to use the interval notation, that's this notation right here. Yeah, that's a weird way to show that. Sorry. Then you could do the same thing by saying these y values start at negative infinity and they stop at 3. The negative infinity is not included because you can't get to negative infinity. Negative infinity is not even a number. 3 it actually gets to and includes. So we're going to do brackets. Okay, so brackets are always for the or equal. Okay? All right, so do you see any lines? No, I'm moving on to asymptotes. Do you see any lines that this graph approaches, but it doesn't actually cross? like, you know, some people want, when they're looking for ways to make this work, they think, well, you know, it never actually gets to y equals 4. Well, while that is true because it goes up and then goes back down, it doesn't continue to get closer and closer to it. So that's not an asymptote. Okay. This particular graph doesn't have any asymptotes. Okay, so please, you know, when you're filling in, you know, you're going to be working on a worksheet. When you're filling in the boxes for asymptotes on this, please either write none. You can write NA. I'm okay if you just even put a line through it. At least I know that you looked at it and you said, "Nope, I don't think it has that," and you said, you know, and you got rid of it. Okay. If you wanted to write me a little sentence like, "Ha ha ha, Mr. Sanford, you can't fool me," whatever, that's fine too. Okay. All right. Well, that's it for those 4 items on that one. Okay. Moving on. We're going to do another one. Okay. Let's do f of x. So this is example 2. F of x equals x plus 1 over x plus 3. Again, we're doing domain, range, vertical, and horizontal asymptotes. Okay. All right. So domain again. What x values are you allowed to use? Well, you can use any x values you want, just as long as it doesn't make something come out goofy. So for instance, square root of a negative, can't do it. Divide by 0, can't do it. Tangent of odd multiples of 90, can't do it. I know that was kind of random, sorry. Log of a negative, whatever that means, can't do it. Okay, so in this case, we can't do divided by 0. Can't have 0 for the answer of the denominator. 0 can be x. 0 plus 3 is 3. That's not dividing by 0. But x plus 3, the denominator, can't be 0. Well, what value would make that 0? Well, I'm guessing that'd be negative 3. Okay, so again, we have options on how to state the domain now. But and really, x can be anything else, just not negative 3. That's the only limitation. Okay, so all we need to do now is write down the domain. So I could write it just x not equal to negative 3. Now, this is not what x is allowed to be. This is what x is not allowed to be. And the implication is that x can be anything else. Okay. Again, you could do set builder notation, the set of all x such that x is not equal to negative 3. I know nobody's going to write it that way unless I demand it, and I'm not going to demand it. Okay. You could do interval notation. Interval notation for this one's kind of ugly. Any number from negative infinity to negative 3, or, and yes, that word or needs to be there, from negative 3 to positive infinity. Instead of writing the word or, you can write a U, which stands for union, which its logical equivalence is or. Okay. All right. I'm going to do a little sketch of this again to talk about range. And so we already know that at negative 3, there's something that can't happen. Okay. Well, in fact, we'll go ahead and do the graph for this. Okay. So it was, I believe, x plus 3, or I'm sorry, x plus 1 over x plus 3. Okay, whoop, back up. Okay, worth noting that unless you are using the little fraction mode here, you have to have parentheses around your numerator and denominator. Oh my goodness, how cool was that? It put parentheses for me. See, this is the fancy schmancy new system. I always kind of just say zoom standard unless I have a reason to do something else. So zoom 6. Okay, and if you take a little peek here, here's that x value of negative 3. And note that this graph is avoiding it like the plague. Now, I just drew in a dotted line there to emphasize the fact that at x equals negative 3, there's a problem. That is your vertical asymptote. Okay, so for this graph, the vertical asymptote was x equals negative 3. Your domain was x not equal to negative 3. Please note the connection. Those two go together. That is pretty darn common. That is not an accident. Okay. Now, if you recall though, the reason we started this silliness was so we could look at the range. Well, let's take a peek at the range, and what I'm going to do is I'm going to push trace on my little calculator here, and I'm going to start going to the right. Okay, so I'm just pushing the right arrow, and on your calculator you can just hold this. Oh, I guess I can on this too. Cool, but it doesn't seem to want to catch up. All right, just keep going, keep going, keep going. All right, so the point of this again was to look for the range. Range is about y values, and my issue here is something weird is going on with the y value. Notice that the y values, they're getting bigger, and so I'm at 0.9. So my question is, it looks like it's getting closer to 1. When does it actually get to 1? Does it actually get to 1? That's my question. And the short answer of this is no, it won't. And you could go the other way and do the same thing, but it's not going to ever get to 1. Okay. 1 for this particular equation is the horizontal asymptote. Let me pop in here with the x equals -3. 1, y equals 1, is a horizontal asymptote. We represent horizontal asymptotes on a graph with dotted lines. Okay, so y equals 1. This graph never gets to 1, so we're going to say y doesn't equal 1 for the range. That's pretty much it for that. I'm going to do a quick little sketcherino. I'm sure that's Italian for sketch. And just so it's semi-complete here. Okay, so let me make a big stink again. Domain and vertical asymptote. Okay, they are often connected to each other. They're not the same thing. They're not interchangeable. It's not always everything about the domain will always be everything about the vertical asymptote. And similarly, for range and horizontal asymptote, there are other issues that play into this, but I will say that it is very, very, very common for there to be a connection. Okay? All right, well, I want to do more examples with you, but time is an issue, and I need you to be able to kind of go back and forth on this video without me continuing on and on and on and on. So for, in class we will see more, and then we will do more later. Thank you very much.